Hey guys, welcome back. Our course is all about trying out problems with different datasets so that you get exposure to a wide variety of use cases which will get you well prepared to work with Hadoop in the real world. We are now going to look at a dataset called Million Song Dataset. This is actually a two-part lesson. In this lesson, we'll get to know about the dataset, what does it have, how to access it, and what can we do with the dataset, etc. In the next lesson, we will solve a problem using the dataset with Apache Pig. First, what is a million song dataset? Million song dataset has metadata for million songs from artists around the globe. This dataset was created by an organization called the Econest and LabRosa, which is a part of Columbia University. The purpose of the dataset is to offer a big enough dataset to encourage data analysts and researchers to design and build and experiment with algorithms on a bigger scale. The best part is that this dataset is free to use and available for download from labrosa.ee.columbia.edu. The complete dataset is about 280 GB, but you can also download a subset of the dataset which has metadata of 10,000 songs, which is about 1.8 GB in size. And we'll use the subset with 10,000 songs in our lessons. Just to make it clear, the dataset has the metadata of the songs and not the songs itself. I'm sure this is disappointing news to people who are thinking to download million songs today. Okay, now let's look at what is in the dataset. To understand, let's look at the description of a record in the dataset. To look at the description, scroll over, click on description, and in the description page, click on Field List. Each record will have key details about the song and the artist, like song title, published year, artist's name, artist location, using latitude and longitude, etc. And also very cool information about the features of the audio, like beats, bars, tempo, etc. But this is where the data gets even interesting. It also has some important information like song's hotness, artist popularity, danceability of the song, etc., represented in numerical values. Pretty cool, isn't it? Now, what we can do with this dataset? Great question. This is what we're going to do. Ever been in a situation where you hear a song and you really love it, but you have no clue who the artist was? I have been in that situation so many times before. Popular artists and their songs are well known. Our goal is to find out less familiar artists but have great songs. Sounds interesting, right? This dataset has artists not just from the US but all around the globe. So to take this a step further, we will also see which artist from this list of less familiar artists is remote compared to all other less familiar artists, meaning who is far away in distance relative to all other less familiar artists. We will also plot artists' location in Google Maps using their latitude and longitude to visualize the data. Sounds interesting? Let's get to work. Before you work on a solution to a problem, there is one thing you absolutely need to know, which is the format, structure, and contents of your dataset. The million song dataset is available in HDF5 format, and it is not human readable. This is where I have my dataset. As you can see, the dataset is nicely organized into folders which are named alphabetically. So drill down to one of the folders. You can see many files under a folder, and each file is with extension .h5. So let's open up a file. Here is the file. As you can see, the file is not human readable. And this is how it looks like. HDF, hierarchical data format, is designed to store and organize large amount of data. There are HDFS libraries available in Java and Python to parse the dataset and pull out the information from the dataset as needed. The website also has utility Java program to parse the contents from the dataset. So this is what I have done. In this dataset, every record contains metadata about a song. So I've modified the Java program from this website slightly to extract just the metadata we need from each song and write the output to a file in text format. You can write a custom input format to read the dataset and get the columns from each songs in the dataset directly for the mapper, but we are going to look at writing custom input format in another use case with a totally different dataset. So for this problem, we'll simply convert the HDF5 file to text format using the Java utility program. Before we look at the program, we need to know what we need from the dataset. We are trying to get information about less familiar artists with great songs. And we are also going to find out the artist who is remote compared to the other artist. So we need to know the artist's name, artist location, which is represented as latitude and longitude in the dataset. Also, we are going to use a column named artist familiarity, which is a floating point number between 0 and 1. Higher the number, more familiar the artist is. So those columns will give us the information about the artist. But what about the song? The dataset has a column named song hotness, which tells us how likable the song is, which is a floating point number between 0 and 1. Higher the number, more likable or more hard the song is. Okay, we now know what we should extract from the dataset. Let's look at the program. So I have a project in my workspace called Million Song Parser. First, look at the class path. We have included several HDF5 related jars to the class path. Now to the program. The program has several methods to extract specific information from the dataset. As you can see, for song hotness, we can call the getSongHotness method. Since the format is in hierarchical data format, the information about the songs are under metadata songs. Any kind of audio analysis information, loudness for instance, are under /analysis/songs. So basically, this program has a function to pull out all the information from the dataset. We are going to use these utility functions to pull out the information we need from the dataset in our just needed song info function and write it to a text file. This function will only extract familiarity, latitude and longitude of the artist, song's title, and song's hotness for each song. There is a lot more information that you can extract for each song in this dataset. And if you prefer to extract all information, we can use the extract song info function, which will extract every single field from each song in the dataset. Now let's see how extract just needed song info method is called. The dataset is nicely organized in nested folders, as we already saw. This program takes in list of folder locations to scan as an argument. You can either give the top level directory where the dataset is stored to scan the entire dataset, or just the list of specific directories you would like to scan. For each folder mentioned in the argument, we'll call the browse folder function, which will recursively scan all the folder underneath the folder that was passed to the program and call the extract just needed song info function for each file in that folder. Extract just needed song info will extract the needed information and will write the contents to a file in a tab delimited format, which makes it easier for Pig to parse and load the dataset. Let's now look at the arguments to the program. You can set the arguments for this Java program by right-clicking the program, go to Run As, Run Configurations, and go to the arguments. So here's my argument, and this is the folder I want this program to scan, parse the files under the folder, and extract the information we need from each of the files. So let's look at the folder location. There you go. Again, as you can see, the folders are well organized in a nested way. So when I run the program, this program is going to go through every single folder and every single file under this folder. This program will write the output to a file in this location right here, million song dataset output, and the name of the file would be songs dataset sample. I think we are ready to execute the program. Let's go ahead and run the program. Okay, the program is running right now. So let's wait for it to complete and then let's review the output. The program is now complete. Let's go to the output folder and let's open up the file. So there you go. Here's our file. So let's open up the file. And here it is. Just the needed information from the dataset extracted in tab delimited text format. I've executed the program already on the 1.8 GB dataset and extract the information we need from 10,000 songs. And here's the output from that execution. And I have already copied this dataset to HDFS. We now have the data ready, and this is our data set that we will use with pig. Now we know about the million song data set. We have defined the problem we are trying to solve, and also we have extracted the data we need, and we have the data set ready that can be used with Apache Pig. Now in the next lesson, we'll write a pig script to solve the problem that we defined. See you in the next lesson.